Yeah, Ketna, hello, am I audible?
Yes, sir.
Ketna, yes, I'm audible. Okay, so in the last class, what we discussed, could you remember?
RL and RC.
RL and RC circuit, right? Okay, so do you have any doubt in that circuit?
No, sir.
No doubt, right? Okay, just completely. We discussed both, right? RL and RC circuits.
Yes.
Okay. I gave you one problem also for the RC circuit. Have you solved that? Ketna? Have you tried the problem which I gave you in the previous session?
No, sir.
No. Okay. You could have solved it. It would be much better. Okay. So look, let's
I'll
do one
solve
thing.
it today, sir.
Okay, fine. Look, Ketna. Yesterday we discussed RC circuit, we discussed LC circuit. I'll give you brief in the first page for both of them. Okay, once. So look, when we discuss about RC circuit, you know what is the way, right? Simply, you know the individual working of each of the different components, right? So if you are good at the phasor, creating the phasor, what you have to do, what are the steps, Ketna? What were the steps of creating a phasor of any kind of circuit when you have multiple R, L, and C? Look, the first phasor is you have to discuss, for example, you have to figure out in this circuit which is common thing, whether a voltage is same for all the component or the uh, current is same at a time. So you know because you are in the this is a series, right? In series, current remains same. So what you can do, take this current as a reference and make the phasor of all the rest of the component for this, okay? For voltage part because current is constant at a time. Understood my point? So in this way, you have to create a phasor. Is this clear?
Yes.
Okay. So for RL and RC circuit, I'll be writing the whole things once in a fast manner. So this is RL circuit. Here you had resistance. Here you had this inductor, right? So you know, Ketna, when you are in the RL circuit, current lags by pi by 2, right? So if I say E is equals to sine, right, E naught sine omega t, okay? So this is actually because current is same, right? So we will not be writing current. Current we will say current as current is equals to sine omega t. Okay. Voltage across this resistance because current is in the same phase. Voltage ahead. Voltage is in this also the same phase, right? So E cross this is equals to something E naught sine omega t plus no as it is. But when you talk about actually this should not be the same. Let's call this as some different component E perpendicular something. Let's not write in this way. E was equals to ER square plus EL square under root. So you have got E is equals to I times of R square plus X L square. Right, Kitna? And we also know XL is equals to omega times of L. What is omega? Omega equals to 2 pi F, or you can also say 2 pi by T. Clear? So omega, this XL can also be written in two ways. L by 2 pi F. Sorry. Wait. What is the top thing? Mm, Okay, I didn't get the command. Let it be. Leave it for a while. Alright, now look. Let's erase it once. Yeah, XL is equals to 2 pi FL is equals to 2 pi F by T. Okay. No way. L by T. Sorry. So Kitna, this was the thing for the RL circuit, right? In AC, you have to remember the behavior of any kind of circuit in AC and DC is different. Okay. If you want me to make a phasor, so the phasor is very simple. Current in this direction, net current. Okay. This is net current basically. Your this is VL. No, this is actually VL is upside. Okay, and this is VR. When I am in RC circuit, what happens Kirtana, in RC circuit? Current is ahead of the voltage. In this case again, sorry, again I made a mistake. You have this, you have this kind of circuit. So current, if you say sine, if some value of current is there at a moment, you can call that as I is equals to I naught sine omega t. This is current ongoing. So ER will be as it is in the phase something. So E net actually comes out as ER plus E times of what is the rest? EC square under root. So I times of R square plus XC square. Okay. If I ask you about what is XC, so that is nothing but 1 by omega L. Omega you already know from here, so you can see this thing as okay 1 upon 2 pi FL is equals to T by 2 pi L. Clear, Ketna? I hope this is fine. If I ask you what is I naught, so I naught is nothing but E naught, the maximum current, right? Maximum voltage which you ever have. So that will be E naught itself. Okay. And also at a moment, you can simply call this as R square plus X C square under. This is impedance basically. So that is the thing we are going to get. Here also the same thing will be there. Okay. I naught will be E naught, E max basically. Kirtana, if this is clear, let's solve one problem, basic problem. Maybe let's go with an example. Okay, Kirtana. So this example is basically given as you are given a bulb. You know, bulb is basically a component. Okay, when we putting bulb, it means we are talking about the resistance of the bulb. Okay, at the end of the day. So assume that there's a resistance. This resistance is basically I'm suggesting there's a bulb. Okay, so I've just replaced this bulb with the resistance of the bulb, and you have an inductor. This is connected in your AC voltage. What is the max? Is 2 and frequency is 250. Okay. If frequency is not given, you have to assume it to be DC. Without frequency, there is no discussion about AC. Ekna, that is fine. Look, this bulb is rated. Rated. What does the rated mean? When you calculated it at some voltage. Here, voltage is given as 100 and 200 watt. 200 watt. This is the rating. This is the rating of the bulb. Okay. Mm, okay, look. Here, this is bulb rated at 200 volt as 100 watt. This is the given data given. What you have to figure out, find uh, self inductance. of this choke coil. Basically, this is some choke coil. Okay. So this is called as a choke coil. Right now, assume this coil. This is coil. Okay, it's a kind of coil. Specific to you can call it as a choke coil. Inductance of choke coil. Okay. Just simply take it as a normal inductor. Don't have to go something such that power or bulb works at rated power. Okay. So Kirtana, you have to calculate the power in that. Oh, this self-inductance. So just calculate it and let clear, Kirtana? Kirtana, look, Kirtana, solve it fast. You have to move to. Kirtana, I can't feel it. Yeah, Kirtana, can you hear me? Please let me know. Hello. Yes, Kirtana.
Yes.
Yeah, solving the problem.
Yes, sir.
Do it fast. Be a little bit fast, Kirtana. A lot of syllabus is pending and we have to do it. But look, Kirtana, after covering this, I'll be covering your rain optics, okay?
Sir, is
What happened? Yeah, Kirtana, you were saying something. Is it? What happened, Kirtana? You were
sir,
saying something. How much? Hmm. Okay, should I give the solution, Kate, now?
Yes.
Okay, fine. Look. Just tell me what are the given data. If you see, you are given the rating of this bulb. So it's better idea to calculate resistance first, right? So let's do that. R is equals to V square rated, V rated, okay, when power rated. This is rated. So this gives you resistance. What is the resistance? This is 100, okay, this is basically 200. The square of it will come out of this. Dividing by this. Resistance you are getting is 400 ohms, okay. Now what you have to do? Leave it. You got the resistance. You can actually remove the rest of the part, but I'm not going to. You want, because the question says, what should be the choke coil resistance such that the power bulbs has a rated power. It means when this circuit is on working, the power consumed across this should be equals to the rated power. That is 100 watt, right? In circuit, power consumed should be 100 watt. Means power is equals to VI, also that is equals to I square R. So if I have to calculate this data, I have this data. So if I use this formula, I have this. No, I don't have this. I don't have this. I have this. So it means I don't have anything. Here I have this. I have this. I just don't have this. So no, I have this. I just don't have this. So I can actually use this formula. So remove it from center. I'll be using P is equals to I square R. That's how you have to decide it now which thing you're supposed to use, which formula when to use. Okay. So I results you out P by R and under root. What is the answer? 100 by 4 under root 1 by 4. The 1 by 2 is the power current. Okay. This is the current you are going to get. Clear, Ketna? Is this clear? Ketna, is it clear or I have doubt?
Yes.
Okay, fine. Um, if you see carefully, we're getting what is equals to I square R. So, right, if we keep I square R, so P was given as 1 by 2 ampere. As per the unit, it should be ampere. Yeah, this is ampere actually. Okay, Kate. Now look, if I go and calculate in a direct way, wait. I think we have done a small mistake, I guess. Okay, let it be. We have not done any mistake. Power is getting this ampere. Okay, it is fine. So ampere, just keep it ampere. Now what you have to calculate now? You got the current, right? How I should go further? To calculate L, you don't have any way. If you anyhow calculate XL, you can use this, right? You can calculate L is equals to XL by omega. So to do this, you need to calculate X, right? How you can do this? This RMS voltage is this. So you need this amount of RMS current. So IRMS is equals to VRMS divided by X Z. Z is the total impedance of the circuit. So from here you got Z is equals to VRMS by this current, right? So RMS is this. So if you solve it out, now you will be getting 400. Sorry, this is 200 dividing by zero point 0.5 will result you out again the same thing as 400 ohms. Okay, this is what you are going to get result. All right, because this is going to be the result in this case 400 ohms. What is z square? Z square is equals to, z is basically 400. The formula for this is equals to r square plus xc square, I think, xl square under root. So when you put the under root, what you are going to get, this is total, okay? So if you put under root, it will become 2, no wait, yeah, this will become 20 is equals to r square plus xl square. Is this clear, Kitna?
Yes.
Okay. There's some mistake I think we have done so far, because look, if you go this way, if you solve it out, this R is itself 400 ohms. So if I go and put R square over here, then I'm going to get some value of XC, XL, which is going to be incorrect here. This is not possible, I think. I have made mistake in problem solving, but okay, wait. I said this is 200 voltage, 50. This is 200, okay, rated at the 200. This is voltage. This is basically the power consumed. Mm, if I went up with that way, I got this 400 maybe. 400 divided by this. The answer was this. Mm, yeah, it's working now. Some mistake we have done somewhere. 400 it is divided by 400 resistance. Power is given as 100. I needed that. So yes, the mistake we have done actually at somewhere. Kirtna, did you realize the mistake? No, not yet. Okay, that is fine actually. This gives you zero point 0.2 amp from zero point 0.5 ampere. So from here, if I use this way, VRMS is given as 200 voltage. So this Z impedance comes out as, yes, this impedance comes out as zero point 0.5 divided by this 400 ohms. I think yes, that is fine. This impedance and this XL. Actually, look, if I go by this way, no way. This I can put in under root of the other side. Sorry, this is the mistake we did, right? Unnecessary, we made mistake. Solving this root part. Okay, fine, Ketna. We just made a mistake in solving this. Look, Z is given as 400. Okay, this is R square plus XL square. What I did is I by mistakenly put under root over here, but it should not be. Squaring both sides will result you around. This is something square. This is something square. Okay, let's call the square of it. So it is like 400 square is equals to R square, and this will become R square plus XL square. But there's a problem. Actually, the question we have taken here is quite incorrect. That's why this will result you out r square also 400, so 400, 400, 0. So it will result to xl equals to 0. Understood my point? So this will result to l is equals to 0. So because the problem is incorrect itself, because I think we have not taken a correct value for this part, that's why we are getting this kind of wrong problem. Okay. Look, ideal way is the same. We just have to solve if the values are if this values would have been correct, you would have got some value of xl and you would have substituted here to get the answer. Okay. By this way, this inductor will be 0. L should be 0. Self-inductance would be 0 in this particular case. Okay. You can try by reversing 200 and 200. Maybe call it as 100 volt and call it as 200 volt. Then you might be getting some good answer. Okay. So this value was the main problem which we have taken here. All right, Kitna, did you understand the way of solving? Leave the value part right now.
Yes.
Okay, fine. Let's do, Kitna, one thing. We have discussed RC circuit. We have discussed LR circuit, right? Uh, let's go for Okay. Now we are going to discuss about LC circuit. If you could remember, we have not discussed it. So how to do this statement? Idea is very simple. You have inductor, you have capacitance, right? L and C. It is in something. You know what is the step gate now? Simply take a reference. So here I'm going to take phasor. Let's create a phasor. Take a reference. So here I'm going to take current as a reference. I. Okay. You know the voltage, right? Let's call this as voltage V L across it, and this is voltage VR VC. Okay. So how the voltage works in this case? In case of capacitance, the voltage lag as per this current. So this will like downside. In this case, it goes upside. This is the thing. Okay. So how to create represent? Assume this is a point. So I'm saying this is VL because in case of inductance, your current lag by pi by 2. So current is behind pi by 2. Okay. In case of capacitance, voltage is behind current. So current is here. It is behind pi by 2. This is VC. Is it clear, Kitna? Can you see the circuit?
Yes.
Understood. Now, if you see Kitna, what is the net voltage you are getting? The net voltage is coming out as if VC is greater than V. Okay, one is VL. If VL is greater than VC, then this will be like this thing. That will be VL minus VC. If VC is greater than this, so something you are going to get. So can I say the net voltage which you are going to get at the end of the day, that is going to be equals to this. Yeah, this is VL and this is VC. So what is the net voltage you are going to get? That will be around this. VL minus VC. Okay. If VC is greater, then you will be having downside. Okay. C minus V. If VC is greater than VL, or if VL is greater than VC. Understood it now this point? So you got the same thing that this is the main current. Okay. Basically, this is the voltage and this is the current I can say. Any doubt you have here? In this case, if you see, we don't have any other parameter for the current. So if I ask you what is the phase in this case, now you can say the phase difference is again coming out as 90 degree. Okay. This is coming out as again pi by 2. Now depends. If this current is greater than pi by 2 as a lagging side, if it is positive, then it will be upside. So can I write it as E is equals to, mm, okay, uh, okay, what we should write? Yes, okay. You know the net voltage will be nothing but VL plus VC. So what is VL? Current across it, I times of XL plus I times of XC. So I comes out as, again, final I comes out as 1 square square square. So this comes out as XC square plus XC square XL square under root. This is something we are going to. Okay. I hope this is fine. All right. Anything else we can say? No. Look, EMF is very simple. I under root XL square plus XC square. Okay. If I ask you, Kitna, what is power factor? You know, power factor is nothing but cos of phi. Basically, the phase difference between this and that. So, if you see carefully, the phase difference coming out as, what is the phase difference? That is pi by 2, right? Cos pi by 2. Either this will be minus pi by 2, either this will be positive pi by 2. So, either way, if you put inside it, this will result you 0 answer. Understood? So, what is the power, average power? That will be equals to E RMS and I RMS, right? Because you know that P naught is nothing but I by 2 R by 2, V by 2. So when you write this, it becomes in the RMS form. Any doubt, Kitna, till now? Till here?
Yes.
No. If you see carefully, the power average is basically this P naught multiplied by the cos phi, right? Power factor. Because power factor is 0, the power average consumed is 0. Can you see one thing, Kirtna? When you have RC circuit, the consumed power comes out as 0. Is this clear?
Yes.
All right. Any doubt you have, Kirtna?
No, sir.
Okay. Look, let's try to create phasor first. You know that, Kirtna. I'll remove this phasor for a while. The already created phasor I'm going to remove, and we'll try to create a new phasor. Look, Kirtna, you know voltage is basically I times of resistance and that, right? So we have two things. I'll be dividing it into two sides. One is XL is greater than XC. Here you will be having XC is greater than XL. Why we are creating like this? Look, one thing. I is same for all of both of the component, right? Now, if XL is greater, can I say VL, because this length represents the magnitude, so VL is going to be greater than VC? Can I say this? Because VL is equals to IXL and this is also equals to IXC. Understood? So you can say the resultant voltage which comes out, the resultant comes out as VL minus VC. Clear? In this case, current is this way. Okay, this L is this. So you can say VL is equals to um, I times of XL. Okay, downside VC is equals to I times of XC. So what is the resultant phasor you are going to get? That is around VC minus VL. Clear? Clear, Ketna?
Yes.
I hope this is clear, right? If you have any doubt, please let me know. So this kind of phasor you are supposed to get. Acha, if I ask you what is the impedance of the circuit, you can see this impedance, right? This only this part is the impedance of the circuit. Yes. Z equals to XL square plus XC square. This is the impedance of the circuit. Okay. And one more thing here, both in both cases, the angle is this. Here also, power factor cos pi by 2 is 0. Here also cos minus pi by 2 is 0. Clear, Kitna? Yeah, Kitna, is it clear? And actually, this mistake I have done here, look at this ones. So I think it is going to work. Yeah, the mistake is, if you see carefully, both of the cases, right? Here you have voltage as this VL minus VC. Here you have voltage as um, VC minus this. So what you can figure out is this Z actually comes out as, what is Z? That is basically V by I. So V is coming out as how much? This V is basically VL minus VC. Both cases are there, right? So it is like it's better to solve in the above part. Here this X comes out as net VL minus VC. This VL minus VC by I. So, sorry, I don't have a space over here. Okay, you can simply call it in another way. Let's call it 0. This Z will come out as XL minus XC. Okay, in a modules. Why mod? Because look, if XL is greater, then you will be having XL minus IXC. Current will be there. Current divided II cancel. If X is greater, then the net voltage will come out as VC minus VL. Okay, in that case, it will be IXC minus IXL. So that will result to XC minus XL. So that is what the answer we are going to get. So it's better to call it as a mod of this. Yes, you can call this as a mod of it. Okay, L minus this. Clear, Kitna?
Yes.
Okay, and by here you can simply say I RMS equals to V RMS by Z. Something like these kind of solutions we have got so far. If you have any doubt, please let me know. So Kirtna, look, let's move to the next page and try to solve further. You know, because in LC circuit, we are right now doing LC circuit, Z comes out as omega L minus 1 by omega C. How I write this thing? Because they both are the same. So let's try to make a diagram. Let's make a diagram because you know this both depends upon omega. I can say how it is moving. Look, Kitna, there's a very simple idea. Your impedance will be decreasing, right? What is the minimum value of impedance? Can you ever have? Yes. If your impedance, this omega goes to zero, if this goes to zero, can I say you are going to get minus infinity as the minus r because this will become zero, minus 1 by 0, this results to minus infinity. So this z it becomes minus, right? When your omega is zero, omega can never be negative. So if this omega is approaches to zero, this is coming from this side, right? Minus infinity to upside, increase, increase, increase by the time. If you increase it like this, you can see there's a point where it is you are going to get having a zero, right? What is the point? This is a point where your ml equals to 1 by omega c. Why? Look, if you see carefully at this point, your this is going to be equals only when you can see here z impedance is zero at this point, right? And impedance is zero here. So omega L equals to omega 1 by omega c. So here omega comes out as 1 by LC. Understood, Krishna, how we are getting 1 by LC? Z equals to omega L minus 1 by omega C. So when omega 0, Z is equals to minus infinity. When Z is 0, then omega L equals to 1 by omega C. This results out, omega goes that side, omega square is equals to 1 by LC. So omega becomes LC. Clear, Kitna?
Yes.
Okay, Kirtna, have you ever seen this kind of thing earlier? Yes. If you could remember, could you remember about resonance condition, Kirtna? LC oscillation, Kirtna. If you could remember in the previous chapter, we discussed about LC oscillations. Could you remember that? Kirtna, can you remember about the LC oscillation thing? So this kind of figure. Also, Kirtna, this is a diagram when your ML is actually greater than 1 by omega c. Understood my point? Basic XL is greater than this. What if your XC is greater? What if your this diagram is greater, this XC is greater? In that case, you are going to get diagram like this. Till here, everything's fine. This case is going to be there. Because look, what will happen, Kitna? I'll explain it. What if your XC is greater? Basically, this is XC, right? And the whole thing is XL. If your XC is greater than XL, it means 1 by omega C will be greater than omega L. It means Z impedance will come out as 1 by omega C minus omega L. Here, if you put omega equals to 0 for a while, what you are going to get the answer is this will become infinity minus this is going to get something around. Okay, let's I'll just first complete this part. X, where is it? Is X L is greater than X. This is the case for that case. Okay, now here you can simply say this is 0 because you are having XL over here. This is becoming 0 and you are getting the answer is infinity. You can say when your omega is 0 and this XL is greater than this case, so this comes from top infinity to this point, okay? This you can call it as XC is greater than XL. Understood? This is fine for now. Let's remove it. Above cases for the X is greater. Acha, what will be the after behavior? The after behavior will be, so what do you think, Irna? After behavior will be similar or it is going to be different? Something like this kind of or diagram you are going to get, okay? That is fine, Kirtna. Any doubt, Kirtna, till now? Kirtna, can we try to make a diagram for, okay, I don't know much page over here. Okay, let's try to create another diagram. Alright, Kirtna, look, now we came back to the last topic, that is RLC circuit we can discuss. Yes, I think we can discuss RLC circuit. One thing, Kirtna, I want to just say, if you could remember this point, here your Z impedance is going to get 0. You know current depends upon V by R, Z basically. So you can see when you have XC is equals to XL, in that case, this current will approaches to infinity. Why infinity? Because you have something V divided by 0. That will go up to infinity. Understood my point? You have to remember this thing. Okay? These concepts you have to remember. I won't say the topic itself. Okay. Something like that. Yeah, let's come back to the last RLC topic. Yeah, after that we have these small things to be discussed about. Look here now, in this chapter, whatever we have discussed so far, most of the discussion happened on the basis of this thing. What is it? Series thing, right? If I gave you a parallel in future, can you solve that parallel thing? Will you be able to solve parallel thing it now? R, this is L, the last is C circuit. Let's make it a little bit big so that it will be easier for us to understand the things. So Kate, now we have to do it in the same way, just as we did in the previous. So here, assume voltage is VR Here inductance is VL, here it is VC. Clear it now? So Kirtna, if you go and just apply this, what I can say, KVL rule, if you go and apply, what you are supposed to get? This is L, this is C. If you apply KVL, V, this is V is equals to V naught sine omega t. Okay. If you apply KVL, you are going to get V minus VR something minus VL minus VC, right? This is something you are going to get. I hope this is clear. Clear, Kirtna? So you can say that V is equals to VR plus VC plus VL. Okay, this is one thing we have got. Let's come back to the phasor thing. Okay, what is the phasor? We have to first create a reference. You can call the reference, you can call it as base. Base or reference should be a common. In this C, you can see, assume some current is flowing, right? I is same, I is same, current is same. So we are going to say this is I. Understood? So you know, whatever the direction this current is having, the same direction this VR will also be having. That is I times of R. Understood, Krishna? Then we can say you have two things. What is it? XC. Then you will be having inductor's current. Inductor's voltage is ahead of the current. So this will become VL. That is equals to I times of XL. And the last one you can call this as VC. I times of XC. Okay, so if I go and get the resultant of the same thing, what I'm supposed to get in this case, again, I can divide it into two parts where your XL is greater than XC or XC is greater than XL. Two cases we can have. I'm just going with to solve for the first case. Yes, I'm going to solve it for the just first case. You have to solve for the rest of the another case. So okay, I'm just going to divide it into two parts. I VI is equals to IR and upside. This is VL minus VC. Which case? XL is greater than X. Right side, okay, this is the right side. Left side we can solve for the other case. This, sorry, this is something like this case. V in this direction, IR. Bottom side you'll get VC minus VL. Okay, here minus pi by 2, positive pi by 2. So if I ask you what is the resultant voltage, look at this carefully. You have a resultant in downside, this. What is the value of this voltage? That is nothing but V R square plus this, whatever it is, definition, delta V square. And this gives you this result. Clear? Here also you will be having upside. So this will be nothing but VR square plus delta V square under root. This is delta V. You can call this as delta. Okay, that is the thing. So here this is resultant V. V resultant comes out as VR square plus delta V square under. I hope this is fine. This data is fine. Okay. Now again, idea is very simple. You have to calculate Z. What is Z? That is impedance. How you can calculate out? This is voltage V. Okay, current basically V divided by Z. I have to calculate Z itself. Simply use either of the equations. So let's use this. V is equals to VR square plus delta. What is V delta? That is XL V. It is not XL. Right in the form of current. Okay. This V is the total, right? So what is the total current? That is V. What's the okay? Sorry. We can write it as total current I and Z. current is same in the whole circuit, so it will become IR square plus inside you are having, right? So that will become XL minus XC, depending upon which item is greater. If XL is greater, you can call it as XL or something. The best part is in this case, these both values are going to be the same. Why? Because XL and XC both are inside the root. So if XL is greater, this will become positive, and after root, positive. If it is less, it will become negative, but due to root, it will become positive finally. So we don't even have to mess about whether which parameter is greater or smaller. Something like this we have to discuss. Yes, Kirtna. So you can just take the I common out and it will get cancelled. So Z comes out as plus C square. Okay, clear, Kirtna? Any doubt till here?
Yes.
No doubt, right? Okay, if I ask you what is the value of this phi? Yes, this is some angle phi, right? So what is this phi? So that phi is nothing but tan inverse of perpendicular upon base. So VL is perpendicular and VC is base. Okay, so this actually comes out as XL by XC. Mm, no, not this actually. Top side is basically perpendicular is X. It should not be the case. Let me just clarify this. Yes. Look, at the perpendicular you have delta V and the base you have just V. So this is basically XL minus XC divided by R is the value. Okay, either whichever is greater you have to keep it in that way. Just don't alter the order. I hope this makes sense. And if you know the phi, you can calculate the power factor also. So this power factor comes out as, what is the power factor? Base, that is R, divided by hypotenuse. What is it? VL minus VC square. So that gives you the value XL square minus XC square and under root of it. This gives you the power factor. No, actually not this. Missed one more point. Power factor is basically the net voltage, right? This is R. Let's call this a simple value, that is Z, R by Z. Okay? You don't have anything on the base, R by Z. You have already calculated the value of Z earlier. Okay? That gives you the value kit now. So let me know if you have any doubt. Okay, yes, Kitna. Any doubt is there? No doubt, right? Wait. Okay, I'll give you one problem to solve it, and that is for the today's session, I think. Let me add one slide. Okay, last problem. Resistance you can take it as 30 ohm, and okay, let's take the inductor as 0.75 pi upside or downside. Okay, let's make it at the downside so that we can cancel out in future. C we can call it as 1 by 3 pi. The reason behind this pi, because you are going to get omega. Omega will be having 2 pi along with it. So I wanted this to get cancelled by itself. So that's why I'm not keeping the pi anymore. Okay, that's why I'm giving pi at the bottom. So look here now, this is the main figure. With respect to this figure, I'll be giving multiple questions in the same problem, in this one problem. You have to solve all the problems in a sequential manner. If you're able to solve all the problems in a sequential manner, we can assume that you can assume that you are crystal crystal clear with the whole AC circuits, okay? Alternating circuits basically. All right, I have already given one problem for RC also. We have not done so far, so solve that also and this also. Just find things in the sequence. Okay, first inductive reactance, capacitor, circuit. Third, explain whether circuit is inductive or reactive. Inductive and capacitive. Look, it simply means, get now the third point simply means whichever, if you figure out the values, okay, whichever has a more magnitude, that kind of circuit it becomes, okay. So you have three things for now. I'll be writing more points. You can solve of them, okay. Fourth, you have to calculate impedance of the circuit. Okay, this fifth point, try to draw phasor diagram, okay. Create a phasor diagram. Then sixth, you can calculate power factor. Mm, Power factor angle, okay. Angle is basically phase. I'm talking about phase. Seventh, calculate power factor. Eighth, you can calculate maximum current. Ninth, you can calculate RMS value. Tenth, you can calculate voltage across resistance. The maximum I'm talking about, okay? Not just the minimum or something. And what next you can calculate? VL maximum, VC maximum. 14th, power average. Okay, basically average power you have to calculate with. So Kirna, look, these 14 points are there which you have to solve as a part of this problem. Clear? These 14 points. Do it in a sequential manner because you look at the order. If you calculate reactance, if you calculate capacitance, then you can tell about the whether it is inductive and capacitive. Okay, you have both of them. If you have both of them, you can calculate impedance. If you have all of these three, you can create a proper phasor. If you are able to create phasor, you can get the angle. If you get the angle, you can calculate power factor. And rest of things are in a sequential manner. Okay. So that's all for today's session. Goodbye. I'm ending the session by this.